I make so much money. There's gonna be an outrageous audit. This is maximum length of subarray with a positive product. Given an array of integers nums, finds the maximum length of a subarray where the product of all of its elements is positive. Okay, so I take a subarray. What does that mean? Any subarray is just any continuous section of an array, right? I take that continuous section of the array, and if I multiply all the elements together, I should get something that's positive, right? Not non-negative. So what are two things you know from that? Well, first, there has to be an even number of negative things, right? Because in order for the subarray's product to be positive, right, you have to have, for every negative, there has to be another negative number to multiply it to negate that, right? Because two negatives together, multiplied together, become positive. So you're going to have an even number of those negatives in order for there to be a positive product. Okay, so we're going to need an even number of negatives. It could be 0, right? Because if you have 0 negatives, that just means all of the elements of your subarray are positive. Okay, even number of negatives. And you can't have 0. A 0. Right? Because this has to be a positive product. So if you multiply something by 0, it's going to make it 0. And regardless of what you multiply after that, it's going to stay 0. So if you see a 0, that messes up your entire solution. Right? The second you see a 0, that can't be in your answer because that 0 is going to cause everything to be 0, regardless of what you multiply, right? When you multiply something by 0, doesn't matter what you multiply it by after that, it stays 0. So for example, if you had this first point, right, if you have -1, -2, 3, right, this subarray is positive because these two negatives negate one another, or these two negatives counteract one another. So you take -1 times -2, you get 2 times 3 is 6, so it's positive. Now, we don't care about what the value is. We just want the maximum length, right? So the length of this subarray is 3. The fact that the value of it is 6 doesn't matter as long as that value is positive. And it can't have a 0, right? If you had a subarray like this, it's looking really good, you can't include everything here, right? Because when you multiply 1 times 2 times 3 times 4 times 5, whatever that is, times 0, becomes 0. Times 6, still 0. Times 7, still 0. Times 8, still 0. So this 0 is a menace, right? It's evil. You include that 0, it's going to make your solution no longer work. So, the longest in here would be probably this subarray, and it has a length of 5. Okay. A subarray is an array of consecutive sequence of 0 or more values taken out of that array. Okay. Return the maximum length of a subarray with positive product. Okay, so which one of these examples are good? So in this example, right, the output's 4 because there's 2 negatives. All right, so that makes it positive. In this subarray, right, you can't take this 0 because remember 0 is going to ruin your solution. You could take this 1. This -2 would make it negative, but then if you include this -3, that'll make it positive again. So, and then you can't include another negative, or that would make it negative again, right? So there's this constant altering aspect where it goes positive and it goes negative. It goes positive and it goes negative. So you can only include an even number of negative numbers, right? Which is why you can't include 3 of these, and then you can't include this 0. This one's a little bit more interesting. So you could take 2 negative numbers, right? You can't take 3. You can't get over this 0 because the 0 messes everything up. Okay. So how do we solve this problem efficiently? I guess the idea here, I'm trying to think of which one of these examples would probably be the best to look at. Maybe this 1, 2, 3, 4. Let's just look at that. So let's look at 1, -2, -3, and 4. Now, one thing about this problem, I guess, which is interesting, is just because something's negative now doesn't mean it can't become the solution later, right? If I have the maximum length of a negative product, all I need is another negative number, and that negative number will make that negative product positive. So what I'm saying is if we kept track of The positive subproduct, the longest positive product and the longest negative product, both of those pieces of information are crucial to finding the longest positive product, right? Because the longest positive product could be a negative product where you just added another negative number, right? If you have a negative, imagine that this, let's make it red. So this is negative, and then we'll make blue be positive. What I'm saying is imagine you had this long product of numbers like this, right? And this is negative, right? So this has length 1, 2, 3, 4, 5, 6, 7. I'm just using x's to say there's numbers there. If I add another negative number, like -1, well, if all of this together, what I'm saying is that this section is negative. If I multiply in this -1, what does that mean it is now? Well, now it becomes positive, right? This whole system is negative, but this whole system is positive. When I'm using the brackets, I'm saying the characters that are with the numbers that are within this black bracket is negative, but when you multiply in this -1, it becomes positive, right? So what I'm basically saying for this problem is if we look at some portion of numbers that we've already found the solution for, being the longest negative and the longest positive, looking at the current number, we can make a decision about what that means for the longest positive up to this case, the longest negative up to this case. So what I'm saying is, for this example, what's the longest positive here? The length of the longest positive is 1. And the longest negative, 0, because there's nothing negative yet. Okay, what about at this case here? Well, if you have a negative number, okay, so looking at this example here, the negative number can only make something positive if there's something negative previously. So the longest positive number here is 0 because there's nothing to attach this -2 to. Right? I can't attach this -2 to something, an already existing negative subarray to make it positive, so it stays as 0. The negative value here, well, it's just 1, right? Because there's a negative value by itself. Now when I look at this -3, what can I say? Well, for this -3, there's a system right before me, right, of length 1 that is negative. So if I attach myself to it, it'll become positive. Okay, and there's a system before me. The system before me has 0 positive. Now, okay, so what does that mean for negative here? What's the longest negative subarray? Plus, this isn't right because okay, I messed up. I messed up big time. I apologize. So the longest positive here is 0, right? Because there's nothing that I can make. There's no positive subarray I can make at this point, right? Because the previous negative array is 0, so I can't attach myself to it. The longest negative subarray here is actually 2. Right? Because with a similar case, the longest positive subarray, so if we did this another example, right? If we had x here, a system of x's that were all positive, I'm using blue to represent positive, right, where this is positive. If I attach a negative to it, like -1, for example, this whole system becomes negative. So there's kind of this relationship here, right? If something's all negative and you attach a negative, it becomes positive. If something's all positive and you attach a negative, it becomes negative, right? So when I attach a -2 here, the previous system is 1, so I can make something of length 2. I don't know why I did -2. Of length 2. Okay? Now for the next system, -3, now -3 can attach itself to something of negative of length 2, right, like this. So this is length 2. I can attach a -3, and I can make it total length 3. Negative 3 can't attach to anything positive, right? Because there's a 0 linked positive here. So there's nothing I can attach to negative 2 to that's positive to make it more negative. So the longest linked negative here would just be 1. And why would it be 1? Well, because the negative 3 itself. Okay. And now we have a positive number. So we really haven't considered what a positive number does. What happens when you attach a positive to the longest positive and you attach a positive to the longest negative? So we'll do that again. So let's imagine we have a system of positive numbers, right? Where this system, when you multiply them all together, they're positive. If you attach a positive number like 3, it stays positive. Right, so if you attach a positive number to a system of positive numbers, when you multiply that positive number, it's still positive. Right, so this new system is also positive. What if you do the same thing for what if you do the same thing for a negative system? So what if all these numbers are negative? So these are negative. What happens when you attach a positive number? It stays negative. Right, because the positive number is not going to change whatever the longest thing is of the previous system, right? So for 4, the longest subarray ending at 4, which is positive, would just be attaching myself to the longest subarray, which is positive, and then adding myself in, and then the same thing for negative. I would just attach myself to the longest thing that's negative. So in summary, what we can do is we can say we'll keep track of the longest positive and the longest negative ending at a certain point, right? So the longest positive ending at an index, we'll just call it P and N actually, okay? So this is the longest positive ending at the previous index, right? So that's like this information. It's this information here. It's the length of the previous system. Okay, and then we look at the current number. If the current number is negative, what does that mean? Well, okay, the current number is negative. If the current number is 0, what does that mean? If the current number is 0, everything zeroes out. So that's just something to think about, right? Because if you have a 0 in this system, then this zeroes out. So that the longest length of that would just be 0. So that's just something to keep track of. Okay, but if number is negative, what does that mean? Well, if the number is negative, the length of the longest positive is 1 plus the length of the longest negative, if there's a negative, right? Because if there is no negative to attach yourself to, you can't make yourself longer, right? The negative can only make yourself longer if it can attach itself to something that's negative already, right? Like when I saw this negative 2, I didn't get a positive length of 2 because there's nothing to attach, or 1 because there's nothing to attach this negative 2. I need to be able to attach myself to some system that's already negative. That way I can make it positive. I can't attach myself to nothing. So positive will equal 1 plus negative if negative is greater than 0, else positive will stay as 0. Right, and that's what we did here. Right, since negative was 0, we couldn't add 1 to positive, so we set it to 0 still. Okay, and the negative becomes the same thing, right? Well, actually, no, because a negative alone can make a system negative. So it can take a positive system to negative, or it can take a system where nothing to negative, right? If something is positive, trying to find where I did that. If something is positive like this and I attach a negative to it, it becomes negative. Even if this system is empty, if I attach a negative, it becomes negative, right? I only need another negative to make a negative positive, right? But it's not true the other way around. So negative equals 1 plus however many positives there are. And if there are no positives, then, and these things need to happen atomically, like together at the same time. Because if I update positive here, then I update positive here, it's going to be an issue. But let's just say for the sake of argument that these are updated at the same time. Okay. Now, what if the number is positive? Well, if the number is positive, we either attach ourselves to the longest positive or we attach ourselves to the longest negative. Because if it was negative, it'll stay negative. And if it was positive, it'll stay positive. But if this is the same case here, right? So negative equals 1 plus negative if negative is greater than 0, else 0. Right? Because I need a system to already be negative in order for it to stay negative, right? There needs to be a negative system here such that when I attach a 3, it's still negative. But if there's nothing here, then when I attach a 3, it's actually positive. So I can only populate n equals 1 plus the previous number of negatives if there's already a negative, right? And then this time positive would just be 1 plus positive, right? Because if I have a positive system and I add a positive, regardless if there's numbers in here or not, it'll stay positive, okay? So that's the whole system. And then otherwise, if the number's not positive, it's not negative, what does that mean? That means it's 0. That what we just say, positive equals nothing, n equals nothing. Because you lose, remember, because this is giving you the number of elements in a row that make a sequence negative or make a sequence positive, right? P is the number of elements in a row that make a sequence a subarray positive up to that point, and n is the number of elements in a row that make that subarray negative up to that point. But if you have a 0, you lose everything, right? Because you can't include a 0. So if you see a 0, there is no subarray that ends at that point that you can use. So you just set it to 0. Okay, right? Like if we did this example here. So let's quickly go through this example again. Let's go through, not this example again. Let's go through another example using this idea. Let's try to, put this in our head and see what we can come up with. Okay, so we have -1. I'm doing this example down here if I didn't clarify that. -2, -3, 0, 1. And then we have our positive, which is blue, and our negative, which is red. Okay, so positive here is 0 because so let's just go through. So we have a negative number. So negative number, we're going to start with P and N equaling 0. So if N is greater than 0, we'll set P equals 1 plus N. N is 0, so there's nothing for -1 to attach to make it positive. So this stays as 0. And then we say negative equals 1 plus P. And P was 0 and is still 0. So then negative becomes 1. Okay. And since we're populating P over and over again, we want the longest P, we should probably keep track of what the maximum P is that we've gotten so far. So that would be 0. So this M is the maximum P that we get because that's what we're going to end up returning, right? Because we're trying to find the longest positive subarray. P will give you the longest positive subarray up to a point, but that might change through the algorithm. So you want to keep track of that at each index, at each element to see which one resulted in the longest subarray of all. Okay. Now we have -2, so we see another negative. Well, if the num is negative, P equals 1 plus N if N is greater than 0. Okay, now since N is greater than 0, N is 1. That means that we can attach the -2 to the longest subarray of 1 and add 1. So now we have a longest subarray that's positive of length 2 ending at -2. And N, well, negative just becomes... Negative becomes what? 1 plus the positive. Right, because whatever was positive now will become negative. There's nothing here, but now it's just length 1. Okay. And then we would check our max and say, okay, our max is now this blue 2. Now we found a situation where we can get something of length 2, a positive of length 2. Okay, another negative number. So let's run through this again. P equals 1 plus N if N is greater than 0. All right, so we have another N equal 1, so we can do another length 2 subarray. Now negative equals 1 plus 3, so now we actually have a system of length 3, right? Because there's a system, there's a subarray that's positive of link 2 ending at -2, so I can attach myself to it and make it negative. Now there's one of link 3. All right, now when we see a 0, this is kind of why I want to go through the example. Okay, the number is not negative, the number is not positive, right? We can't attach a 0 to anything, because if we attach a 0 to this, it's no longer negative, right? It's no longer, no matter what I attach it to, it's going to become 0, which is non-positive and non-negative, right? So there's nothing that uses a 0 that's positive, and there's nothing that uses a 0 that will become negative. And then we just have the same example here with 1. If I attach myself, if with a positive 1 here, right, n equals 1 plus n if n is greater than 0. Right, I can't attach myself to a negative and make it more negative because there's nothing negative before me, so this is still 0. This is 1. This is 0. Okay, so with that, let's go ahead and just run through the problem using this example as our. Okay, so we'll say m, p, and n equals 0, 0, 0. Okay. And then we'll look at each num and nums. So if num is greater than 0, else if num is less than 0, else. Let's do this first, right? If this is the case, we just said that p and n equals 0, 0. And then after each check, we'll say m equals the max of m, and the longest subarray ending at an index would be the positive value here. All right, if num is greater than 0, what are we doing again? Okay, so the number is positive. That means that n and p will be updated. So positive and negative will be updated how? Well, positive will just equal positive plus 1, and negative will equal negative plus 1 if negative exists, else just negative, which is 0. We'll just call it 0. Okay, how about if num is less than 0? The num is less than 0, our positive and our negative. Well, our positive becomes negative plus 1 if negative, right? Because if there's a negative number, when we multiply in a negative num, because num is negative, if we multiply in num, which is negative, then it'll become positive, but only if there's a negative sum of from the previous index to attach yourself to. And then this just becomes positive plus 1. And then we can kind of put these on less lines here. Now, I've already solved this, and I've seen previous solutions, and I feel like mine is one of the more approachable ones. But my explanation was pretty poor today. And at the end, you just return m, because m is that max, right? Pending, judging, submitting. Okay? And there you go. Okay, so what's the runtime and what's the space? Okay, so let's say n is the length of nums. So we have to, for time, all we have to do is look at each number. This is a constant operation. This is a constant operation. This is a constant operation. This is a constant. So I have 4 constant operations, right? There's nothing in here that depends on the input. I just make a couple of decisions on updating 2 variables based on what num is, but I have to look at each num. So I have to do n operations, right? Because I have to look at all n numbers in the array. And then for space complexity, well, I create these 3 variables, and that's all I update through the system, right? I just keep updating these 3 variables, and at the end I return it. So that's just constant space. And yeah, there you go. Hopefully this made a little bit of sense. I was rambling a little bit. I hope maybe I should have used more of a graph model to kind of describe this notion. But I guess the idea is what happens to a negative sum ending at a certain point? If you attach a negative number, it becomes positive. What happens to a positive sum when you attach a negative number? It becomes negative. What happens to a positive, something positive ending at a certain element? If you add an additional one, it stays positive. If it's negative, it stays negative, as long as there was a negative sum that existed. All right, guys, have a good one. Peace out.